Hello, everyone. Welcome to another episode of Cuda Education. Today, we're continuing with the gears.cpp algorithm in the next function in line. First of all, thanks to Sascha Willems for providing this code. It is freely available on GitHub, and I use the code to understand the Vulkan API. So let's get into it. The previous video to this one in the series is talking about uniform buffers. There is one thing I forgot to mention. If you look, remember I said that uniform buffers are for they're about updating the model like rotation wise so that you see the rotation on the screen, right? So the way how there's a feature in the animation where you could press the P button on your keyboard, and when you press the P button, it pauses the animation. What pause really means programmatically is that you are restricting the update uniform buffers function from working. So if you see here, if you see the animation working, right? And then if you press P, it stops. Okay? And then if you press P again, it works. Okay? So what's happening when that happens? When you press P, if it's not paused, it does update uniform buffers, but if it is paused, it skips over this logic right here. So the render logic, when it's called, it's no longer updating uniform buffers, and because of that, you don't see the rotation actively happening on the screen, right? So there's no rotation happening. Now, if you press P, this test pass, and then it updates uniform buffer, right? Sort of, if you don't believe me, I could comment out this right here. And then what basically will happen is that the gears never rotate, right? No matter what I do, it never rotates, right? I could press P all I want, whatever. The gears never turn on. And that makes sense because now there's no way for the Vulkan API to update the uniform buffers for you to see the change in rotation of the gears, right? So let's put it back. And then we will see, you will see that it's rotating, right? So that's basically what's happening there. All right, so that's a uniform buffer piece. All right, the next function that we're gonna have to discuss is buildCommandBuffers. Now, we've done all this work up to now, and now we're going to build command buffers, right? And it's sort of the last piece in the series of tasks that we're gonna do, and basically it's the last thing that I'm gonna kind of discuss in this gears.cpp series for now. If there are other updates in the future, I will I will definitely come back to this. All right, so go to definition. Build command buffers. All right, so let's just hang out here. It's a fairly long piece of code, but don't feel intimidated. We're just gonna discuss a couple of key important things and then be done with it. All right. The first thing you notice is that there's a begin command buffer section and end command buffer section, right? So all of this right here is your beginning command buffer and end command buffer. What is a command buffer? Is basically you're recording commands that needs to happen, basically that needs to be performed, and you're recording it and you're building it in so that Vulkan knows what it is you want to do, when you want, and how you want to do it, and it has full transparency and visibility on what you want to do. It has been said that this command buffer stuff, the way how it's, because of the command buffers, there are opportunities for optimization because Vulkan kind of knows what kind of comes next, and therefore you could it can optimize and do shortcuts or throw out things, resources that it doesn't need and all that stuff. But you know, we're basically recording a bunch of commands, and those commands are run, and you know, that's pretty much what we're doing. So we have a begin command buffer here and an end command buffer here. All right, that's the first thing. The second thing is that there's a render pass. Okay, so there's a render pass in between the command buffers, the begin and the end. Right, a render pass is pretty much, you know, when you want to do modifications, you want to add stuff, take stuff out, you want to you know, just basically make modifications to the image or to the situation that's being rendered to the screen. You know, it's been a while. I kind of stepped away from the Vulkan API for a second, and now I'm back into it. So I'm not 100%. You know, I've done videos on it and all that stuff, but yeah, I need to refresh my memory some more. But basically, you have your command buffer, and in the command buffer is included a render pass, right? So you know, that's those are the two main components, and then you're cycling through this draw command buffers variable to basically, you know, generate all the things that you're doing. I guess this is the gears for loop, which we have seen before, and then notice I'm going to assume it's going to be 3 of them because it's 3 gears that we have on the screen, and you know, that's about it. Notice that the begin command buffer and end command buffer are these special VK functions. So we know we're really dealing with Vulkan at this point. Begin command buffer, end command buffer. Also, begin render pass and end render pass are also these lowercase VK functions. So we know that that's really important. The thing that really was I kind of was trying to figure out is that, you know, we do all these tasks here, right? We do prepare vertices, set up descriptor set layout, prepare pipeline, set up the descriptor pool, set up the descriptor sets, update the uniform buffers, and I'm like, cool. You know, all of this stuff is great. It's a bunch of typing. It's a bunch of, you know, things that we have to do, things that we have to set up. And then I'm looking at this and I'm like, okay, cool. You know, we did all this work. You know, I see that we have this final function called buildCommandBuffers. All right, I see that we begin the command buffer, we end the command buffer, right? We begin a render pass, we end the render pass. We do all of we create all these variables, and we have all these initializers, which, I mean, they're not that, you know, they're not that involved. It's just, you know, it's kind of just declaring certain types and stuff, right? These are not that involved, so I'm not even going to spend much time with this, right? But you know, what I'm saying is that we do all this stuff, and of course you have this render area offset and stuff. Cool, whatever. We're looping through this variable called draw command buffers. I'm not really sure. I know where it's initialized. I could go to definition and see that it's initialized here in this file, in the base file, Vulkan example base file. I get that, but like, where does this size is? Where is that being defined? And like, you know, how does it know how many times to loop and stuff? But okay, we have this for loop. We know about the gears here. I get that it will be like 3 gears, right, that we're looping through. For each one of the draw command buffers loops, we do this for loop for the gears, I guess, right? Okay, I get that. But my biggest thing was, what connects all that we have done before to this? That was my biggest question. With all the work that we have done before, what connects all of this to build command buffers, right? It's a whole bunch of typing. It's a whole bunch of moving parts and things that we're doing here, but what really connects the work that we have already done, the things that we've already declared, the models, the SPV file, the load shader, everything, you know, the pipeline, the descriptor set, the layout, you know, descriptor layout, everything. What connects this final piece to all that we have done before? And after kind of really paying attention, I realized there are two main things. This command here, right? And this command here. All right. And that's sort of the connection between the work that we have done before and this particular build command buffer call, right? So VK command bind pipeline. If you Google it and you look at the spec, it will say bind a pipeline object to a command buffer. All right. So bind a command line object, bind a pipeline object, bind a pipeline object to a command buffer. All right. Okay. That sort of makes sense because we have sort of encapsulated everything that we have done into this pipeline construct, right? So let us just investigate. Right, the pipeline is definitely created even within the gears.cpp file, right? So let's just run through it real quick. Okay, we have the destructor there, that's fine. We have that there. Prepare pipelines, right? Remember that? That was one of the tasks in one of the videos, right? So prepare pipeline. So all of the work that we have done here is now is now captured into the pipeline variable, and not only the pipeline variable, but the pipelines.solid handle, right? So the pipelines.solid handle. Okay, so all of the pipeline stuff we know is covered. Cool, I get that. Let's get back to where we were. Where is it? Right, okay, so all right, we understand that. This VK pipeline bind point graphics. If you Google that and you look at the spec, it says VK pipeline bind point. Specify the bind point of a pipeline object to a command buffer. Okay, specify the bind point of a pipeline object to a command buffer. So we know we have our pipeline object, right? And then we know that this whole thing here is dealing with the command buffer. Cool. So this is saying we're gonna VK pipeline bind point graphics. Okay. So if we run this as it is right now, right, we're gonna see that it's it runs as we expect. No problem, right? It's this. Cool. There are other options that we could use. Let us do compute. Okay. Let's change it to compute and see what happens. And you see it crashes, and that's a good thing, and that's to be expected because all of the work we have done so far, is graphics related, right? So it makes sense that the pipeline. What's the definition here for this thing? It's this thing. This. If we go here, right? VK pipeline bind point, right? That's the type of the variable that it's expecting. And that is specify the bind point of a pipeline object to a command buffer. Okay, makes sense. So we have this command buffer thing, and we're trying to join the pipeline that we've created to it. And we know that it's a graphics pipeline, so that makes sense. All right? So that's the VK command bind pipeline function. All right, so we get that now. The next thing is the gears. Okay, so now we're cycling through the gears, and we use the pipeline layout situation to help us draw the gears. And if we go to pipeline layout, so let's just search for pipeline layout. All right. This is a setup descriptor set layout. So as part of the setup descriptor set layout, we eventually got to declaring to the the pipeline layout, which is like I guess a cousin of the descriptor set layout, right? So we initialize the pipeline layout create info. This is a helper function, and basically we attached everything regarding the descriptor set layout to this pipeline layout variable, and then that's what we use to basically attach to the when we're drawing the gears, we use that variable here. I mean, I'd have to dive in more to figure out exactly what the relationship and why this particular variable for this instance and stuff. But for the time being, these are the 2 points of entries of how we connect what we've done, the work we've done before, with this command buffer here. And then we do a bunch of other things. All right, so that's how we make this command buffer thing relevant, because if we didn't see these things, I'll be like, okay, there's a whole bunch of things happening here, but how did we connect all the work that we have done before to what we're doing now? And this sort of helps to give me a little bit better context on Vulkan. I don't mean to toot my own horn or anything, but I feel that what we're seeing here and what we're talking about and discussing here is actually very helpful to really understand the relationship of things in Vulkan. It's very hard to do it looking at the spec or just reading about it online, or reading a bunch of posts on forums online and like trying to piece together how these things relate to each other. But if we could kind of see, the command buffer is a bunch of commands and instructions that are basically saved and looped through every time we're doing a new frame and everything. So we could now see why we did all this work with the pipeline, and even the idea of a pipeline is now becoming more of a reality for us, because now we understand that, okay, we do all this work to create the pipeline so that when we run the command buffer, we could reference the pipeline and basically shoot the pipeline onto the command buffer and then onto the screen, right? And this is how this is how it's connected, right? These are how it's connected. Cool. All right, let's kind of move on now. So we have our command buffer. We're doing a bunch of stuff. We know that the render pass basically is it's actually doing the work of actually rendering to the screen, right? We have the command buffer, but we also have to have the render pass. But let's test this theory out. Let us comment out the what you call it. Let's comment out the render pass piece. All right, so let's comment it out. All right, so we're gonna okay, first thing that you need to learn is that the algorithm doesn't crash, okay? So it's not like Vulkan is complaining that, hey, what you're doing is wrong necessarily. The other thing we notice, of course, is that nothing is rendered to the screen. Makes sense, all right? Nothing is rendered to the screen because there's no render pass, okay? So the other thing I wanted to do was I wanted to say, okay, this is the render pass and all that stuff. I want to try. I want to try and I want to try and do. I want to draw this little UI thing. The UI thing is just a box in the corner. We'll see it when we go back to normal. But the UI is just a little box in the corner. But I want to do it outside of the render pass. Like, can I draw this thing outside of the render pass, in between the command buffers, right? So the command buffers begin and end, right? Begin command buffer and it begins and end. But I want to draw this UI outside of the render pass situation. Can I do that? It's just a stupid question I want to ask, right? So if I go to do it again, basically it doesn't even recognize my request, right? It doesn't do anything. Now that's my belief that it just ignores it, or it doesn't, what have you. But let's just go back to normal for a sec. Okay, so if we do our thing again, we'll see that it works. Okay, so it's there, right? No problem. Okay, and we could pause this stuff as before, right? All that stuff. Okay, and then this was the UI I was looking for, right? Okay, cool. So we know that we need the render pass in order to do what we're doing. And then that little box in the corner was what I was referring to. The other thing I wanted to see was, what if I commented out the whole thing? Like, what if I commented out the begin and end command buffer? What would happen? Right? Would it still run? All right, it will still run, but nothing shows, right? So I guess it's the same idea, is that you know, you need a command buffer and then you need the render pass, right? Let us try to do something else. Let's forget about the command buffer and just try and do the render pass itself without it being encapsulated in a command buffer. Will it work? I don't know. It does work, but okay. Maybe there might be a validation error or something. I'm sure we're just not seeing it. But you're not supposed to do that. You need to do these things in a command buffer, right? Let me just try it again just to make sure that I'm not fooling myself. All right, it still works, right? But maybe it's implicitly doing it, or it's throwing a validation error or something, but it still works. Okay. Let us comment out the gears. Okay. Let's see what happens here. All right, so we still have our user interface thing, but there are no gears, and that makes sense, because there are no gears. All right, so we need that. I mean, obviously, I'd have to do some work to figure out exactly the relationship with this and these guys here, but that's a video for another day. Subpass context inline. VK. 1 second. Okay, VK subpass contents. Specify how commands in the first subpass of a render pass are provided. Okay, so VK subpass contents inline specifies that the contents of this subpass will be recorded inline in the primary command buffer, and the secondary command buffers must not be executed within the subpass. All right. I kind of know what they're talking about, but it's not really relevant for this thing. Just know that it's the contents of the subpass will be recorded in the primary command buffer. So I believe this is the primary command buffer, right? We're not dealing with secondary command buffers and all that stuff. So I guess we'll get to that another time. That's pretty much it. And I think for now I'll be done with the gears.cpp section of the algorithm. I mean, yeah, I'll be done with gears.cpp for now. I'll move on to another example probably, but there you have it, guys. So, you know, we've done all these steps. We have this flag called prepared equals true, which only, I guess, assuming we do all these things, it reaches this. Right. Once we finish all this, we flag it as prepared as true, and then that means that the render can take place, right? The thing is that I'm not really sure how the algorithm is fully initiated, but basically I'm going to assume that this function has something to do with the render pass and all that, but let me not get ahead of myself. But yeah, that's it, guys. We've kind of done everything here. This very early one, Vulkan Example prepare. So we're initializing a bunch of resources and a bunch of things that we need. But this is part of the base Vulkan Example base. This is part of the base situation. So we reuse this for all of the examples. All right. So anyway, remember to like and subscribe, share the videos, also tutorial number 1 and tutorial number 13, if you want to be able to run these algorithms on your Windows machine with a Vulkan capable GPU. Links in the description below. Love to hear you guys' thoughts. If you have anything constructive to add, please let me know. And that's Vulkan, guys. You know, I think it's important these videos are, you know, help to take abstract concepts and just kind of make them more concrete and make them more concrete and real world. Like, you know, now you could see the importance of building the pipeline and how it affects the bigger scheme of things and a render pass and a buffer. All right, guys, I'm done. Take care. Bye-bye.